Awesome. Hello, everybody. Welcome. It is Thursday. We are here for our weekly webinar. And we are so glad to be here. And if you are on YouTube, you can do like, a little subscribe, a little notify. When you do that, then you get notified when we are live. And we've got always amazing, cool things to talk about. And today we are with Mr. Dave Godlove. Thank you so much for being here. We're going to be talking about Singularity, specifically Singularity Def files and how they work. But just one thing before we get into that, Dave. It is somebody near and dear and close to our hearts' birthday today.
Whoever could that be, Rose?
Whoever could that be? And I don't know why he's not here with me on his birthday. I'm just kidding. I know. You guys probably know him as Zane, Mr. Zane Hamilton. He is the host of this show. Normally, I am co-host. He is off today, enjoying his birthday. Hopefully, there's some sunshine and some cake and some party hats. I want to see a picture. That's where we're at. So happy birthday, Zane Hamilton. We are so glad that you are alive and well, and glad to have you. Okay, so now let's get into it a little bit. I, of course, have a million questions, but I am just going to zip it for one moment while you do a little introduction and a little quick background of Apptainer and Singularity.
Sure, yeah. So I'm Dave Godlove. I'm getting over being sick, so I'm sorry if my voice sounds kind of weird. I'm in a different state than I normally am. I have a very handsome spare bedroom behind me, as you can see. Yeah, so a lot of things are different. But yeah, so I'm Dave Godlove. I've been around the Singularity / Apptainer community really since it started. Have contributed, and it's just kind of been a hanger-on and watcher of things, and sometimes a doer of things within the community for a long time. And so I'm a scientist, used to be at the NIH, used to be a neuroscientist. We just did a webinar, which was a lot about that kind of stuff recently. And so Singularity, which is now Apptainer, was originally created with the intention of basically filling a space in that was needed with Linux containers, which was how do we run jobs in containers instead of services, essentially. And that was a need, that was part of the need that the high performance computing world required. And another need that they had was how do we run containers with more security than was allowed or available at the time. And so that's basically how the project started. And since then, it's taken off really within HPC primarily, but it's become a huge project that everybody just depends upon, just relies on now.
Yeah, that's awesome. I love stories of like the genesis of how things became, right? It was like there was a need, and then there was an idea, and then now, I mean, everyone knows of Singularity and or Apptainer and are using it. And of course, I am going to interrupt you probably a million times and ask a million questions. However, if you are watching and you have a question, just jot it down in the comments section, whether you're on YouTube or on LinkedIn. Either way is totally fine. We do have other people behind the scenes. I don't know. I am definitely like a do one thing at a time kind of girl, right? Like the multitasking of looking all the different places. That is not my job, which is a beautiful thing. We have other people to do that. So you ask your questions, and then towards the end, as we kind of wrap up, we'll be answering all of your questions there. So awesome.
And I should say, too, that there's been I was a little wishy-washy originally about what the topic of today's conversation would be. So I don't think we're actually going to talk too much about def files. I thought that maybe we could kind of dive into the internals a little bit of Apptainer, like the containers themselves. And we can start talking about some metadata and some internal stuff there. This is going to be kind of deep down in the weeds, but I think it's fun stuff to look at and to think about. And it'll give you hopefully some new ideas for things you can do with Apptainer, and also give you a sense for like just how things are working, deep down under the covers.
I like it. Thank you for that correction of my title.
Yeah, well, that's my bad because I was a little like, Maybe I'll talk about this. Maybe I'll talk about that. I don't know.
Okay, that's awesome. All right, perfect. Okay, yeah, let's dive into it. So what is the Singularity D directory? That's it, right? That's what we're talking about?
Yeah. So it's a hidden directory. So it's actually the /dot singularity.d directory. And yeah, so like containers, Apptainer containers, they can do a lot of things. There's a lot of like actions associated with these containers that you can do. You can like, run them or shell into them or exec them. There are predetermined actions that happen when you execute the container as an executable, or when you use the run script via run, and that stuff's got to live somewhere. There's an environment with environment variables. There's metadata like labels and stuff like that, and all that stuff's got to be in the container somewhere. It's got to be associated with the container. So that is basically the way that stuff works, is that there's a hidden directory at the root of the file system within the actual squashfs file system that lives inside of the CIF file. And that hidden directory is called /.singularity.d. And if we look in there and start poking around, we can find actually like the internals of the container and what makes it work, aside from just the file system itself.
So why is it a hidden directory, and what does that mean?
Yeah, so whenever you put a dot in front of a file or a directory with the Linux file system, it makes it a hidden directory. And I think usually the idea there is that, when you want to list the contents of a directory, those are things that you're probably not looking for usually. And so what happens is when you list the file or the contents of a particular directory, things that are hidden are not shown by default. You have to add another flag to show all the stuff that's hidden. And so because of that, then you end up, it just makes things easier to look at. Maybe I should just go ahead and I'm on a new computer, and it's a Windows machine, which is insane. I haven't used Windows in like 10 years. Yeah, so I've got a new personal Samsung machine that's got Windows on it. And I'm going to try to share screen. Maybe I should just dive into that. And then if I can, and then we can go through and kind of, start to just look at some of the stuff instead of having me talk about it.
Cool. And if you're at home, I think we can add a little link here too to a little bit.ly for the Apptainer deep dive for people. Maybe we can just like pop that in the chat there for them so that they can continue on their search and inspiration with Apptainer. Okay, there you go. Yeah, I can see it.
Cool. So yeah, I can't see anything except for my screen now because it jumped to a new desktop. But yeah, go ahead and let me know if things catch fire behind me or if there's anything else I need to know about going on.
Okay, for sure.
So yeah, we were just talking about hidden directory. We can just start off really quick just talking about hidden directories with Linux. So if I do like an ls-l, which I have a shortcut to that, which is ll, it's just going to show me I've got a couple of directories here in this demo user or demouser, as you may wish. I've got a couple of directories here, go, and then June 13 demo, which is what I'm going to be looking at here. But if I could do an ls-la, so, or just a, let me just do ll, which is an alias for ls-l, and then give it a -a. So that -a means all. If I do that, this is why hidden stuff is helpful, because all this kind of gets in the way, right? Probably what I want to look at is either this June 13th demo or go, and they're here, but there's all this other hidden stuff in my home directory too that I probably am not looking for when I just list the files and directories normally. Does that make sense, Rose?
Yeah. I see all the dots.
Yeah, cool. So, okay, and that pertains to what we're talking about today, because .singularity.d is a hidden directory. Let me go ahead and cd into this June 13th demo directory, and I'll show you that I've already downloaded a few containers. And what I did is I downloaded this lolcal CIF container, which is a container that, I'm sure most of us who have been around the Apptainer community for a while are probably familiar with. If not, you'll see it today. I downloaded just a plain Python container to demonstrate something else that I want to talk about a little bit later. I converted this lolcow.sif just into a directory, just so we can like look at it and go through and see what's inside of it. And then I've got some other containers that I created using definition files. There's one I call tree.def and there's one I call vim.def. And we'll talk about those later as I'm trying to demonstrate different things. So I don't know. Do you have any questions to begin with, Rose, or should I just kind of dive in and start talking about stuff?
I guess you should just dive in and start talking about stuff because I'll probably take us off on a tangent.
Okay. Well, I mean, feel free to follow tangents too if you like, but
Yeah, I mean, I guess
today.
I was just wondering. I mean, if you're gonna open the door, like when you say you downloaded this, so are these containers inside of containers, or where do these containers live? You have like a special demo environment, and that's where they all are.
So yeah, no. So this is just on my laptop. Excuse me,
Mm-hmm.
my voice is going to be coming and going. This is just on my laptop, and I just have a new user that I created called, well, it's up for debate what it's called, but demo user, debouncer, whatever. So this new user, I just have created this June 13th demo directory, and I've pulled these containers using the commands like Apptainer, pull. Let's see if I've got one saved. Yeah, so that's the command that I used to pull this lolcow.sif container, for instance.
Awesome. And then a
then
side
to
note
create,
question. Oh, sorry.
sure, go ahead.
Yeah, no, because okay, so we're talking about Apptainer, and like I know the history of what happened with Apptainer and Singularity, but then it's called Singularity.d or
Oh
slash
yeah,
Singularity.d. So
yeah.
does that
So
get
for
confusing
backwards,
for other people?
yeah. So for backwards compatibility, anything that was named like one thing was most of the things that were named one thing, especially like internal, still have that same name. So for instance, this is a very important directory. Let me just show it to you as we're talking about it. So remember that I took this CIF file and I built a sandbox out of it. I did that with like an Apptainer build sandbox lolcow and then lolcow.sif. And I'm not going to execute that command again, but that basically takes this CIF file and creates a bare directory out of it. So let's jump into that and have a look. So if we go into it and then I do an ls-l, it's a root file system of it's a Linux root file system with a couple of funny kind of new files, new symlinks. And so these are called Singularity because these have been around for a long time. These have been around before Singularity entered the Linux Foundation and changed its name to Apptainer. And so because of that, if the new version of Apptainer, which has changed its name, wants to run old containers, it has to be aware of this naming convention that important files are going to be called, Singularity. And notice that they're pointing to this place .singularity.d. And once again, we can't see that because it's hidden. But if I do a ll-a, now we've got some more files here, right? And a lot more of those are pointing to that .singularity.d directory. And in fact, we can see now this .singularity.d directory. And if I cd into that, and then I run the tree command to just see what all is in there, we can see that we have several directories, actions, bootstrap history, which is interesting, environment, libs, and then we got all these files, right? These ones are kind of interesting because they have the names of the subcommands that Apptainer uses. I'm going to be saying Singularity a lot because it's like right in my face to say Singularity a lot. But yeah, anytime I say Singularity, I mean Apptainer as well. I'll talk about the bootstrap history later. We have an env directory, which has to do with environment variables, and I'll talk about the details of that momentarily. We've got labels, libs, which doesn't have anything in it right now. run script, start script, and then we've got this, of course, a file called Singularity as well, because why wouldn't we have that? So, so to answer your question, Rose, a lot, like, I used to joke that within the Singularity, before we changed our name to, before the project's name was changed to Apptainer, within the Singularity like ecosystem, everything was called Singularity, and it was really confusing because anytime there was any like new file we added, or new directory, or new configuration, or new anything, we just called it Singularity, and it was really confusing.
So careful what you wish for. You wanted a new name, now you got a new name, and now it's also confusing.
Yeah, right. Because it all like, it has to be backward compatible and point back to like old school stuff. All right. Let's see. So should I start talking about the contents here, or do you think there's any more questions before I jump into that?
Yes, I think it's great. Do that. I will actually go check on and see if we have any questions coming in so far. Nope. No questions so far as I can see. So carry on.
So one of the first things that you'll notice, like let me make this explicit. If I do an Apptainer yellow help, well, maybe this doesn't make it more specific. There, some of these commands, Apptainer's got a bunch of subcommands, but there's a subset of these commands that we refer to as the action commands, and that includes things like exec, shell, run, test, start, if you're talking about image start. So let's just go back and look and see at the contents of this directory again. Well, I'll be darned. So we've got under the actions, we've got exec, run, shell, start, and test. So right off the bat, you should be thinking to yourself that, there's something interesting about those. So these are actually internal shell scripts that they're kind of like drivers. They make the container work. So let's look at the shell command, for instance. If we do like vim actions shell, we can see this script. And so when you run a container, this is actually the script that gets, when you execute the shell command within a container, this is actually the script that gets run inside the container to make everything work properly for you. And so it's kind of like a pretty simple solution to like run this script to make the container, like to have this directory full of like bash script drivers to make the container work. But that's just how Apptainer works. It's pretty simple. So if we step through and we look at this, we have a for loop. And this is basically saying for whatever the star says, for any file which ends with .sh, which is in the directory singularity.d environment, do something. And whatever iteration we're on, call the current, thing that's in that directory script. And then, so what are we going to do that number of times? Well, we're going to say if that new environment variable that we just named, script, is a file, then source it. And that's what that dot means. Source the file.
Is this something that you would want people to actually be able to see clearly?
So yeah, this is what's cool about this. Yeah, this is what's cool about. Oh, go ahead. I'm sorry. Do we have a delay?
No, it's dark.
Oh, is it hard to see?
Yeah, so it's like the background is black. I mean, some of the writing is white and it really pops, and it's like, okay, I can see exactly what we're talking about, where it says script and singularity.d environment, the little star. That pops out really good. But the other things are like black on blue and some kind of, I don't even know what.
I can't remember. There's an option. Ooh. Mm-hmm. There's an option to set the background equals dark. Is it equals? Yeah. Here, let's do this. There. Is that better?
Oh, much better. Thank you.
Okay. Yeah. So I thought that you were asking at a higher level. Is this something that your average is this file something that your average user you would want them to see? But you were asking, do you want people viewers of this presentation to be able to know what you're talking about? So a little different.
Yeah. It's like, here, let me show you this thing. Do you see it? Do you see it?
Yeah. So hopefully now we can see it a little bit better. So we're saying there's this for loop, and it's saying basically for every file which ends in .sh and is in this environment directory, source it. And so this is basically what sets up your environment inside of your container. And we're going to go through and we're going to look in this env directory shortly, and we're going to see how there's this whole series of scripts, and they all get sourced in order. And these scripts determine what your environment is whenever you run your container. So that's the first thing that happens. And so then the second thing that is going to happen is we're going to say, we're going to test to see if there is a environment variable set called Singularity shell, and whether or not it's empty. And if it's not empty, and if it is an executable, then we're going to try to use that to start up the shell process. Okay, so Singularity shell, if that exists, that environment variable exists, we're going to use that as our current shell. And if that doesn't work for some reason, we're gonna say, whoops, nope, that didn't work, and then we're going to exit with an error code. If that environment variable does not exist, or if it's not an executable, then we're just going to look for bin bash inside the container. And then we're going to set a prompt, a PS1. We're going to export that prompt, and then we're going to just execute this bin bash with any arguments that the user passed. And this no RC says don't source a .bash RC file. In other words, don't set the user's configuration for their shell in this new container. Else, if we can't find bash, we're going to look for sh, because that should be in almost any container. And then we're going to try to start a shell using bin sh. If that doesn't work, we're going to say, I don't know what to do because your container doesn't have a shell in it, and we're just going to exit with an error. So this is one of the cool things about digging through the internals here, is because I might have known at some point in time that this environment variable Singularity shell was available, but I forgot about it. And so in like prepping for this and going through this stuff, I was like, oh yeah, there's this variable Singularity shell that I can use to change what shell actually gets started. And so you can learn new things by digging through stuff like this about the capabilities of Apptainer and what it can do, and then that can trigger new ideas for how to use it and stuff. So let's test that. Let's test how that works. All right, so I'm gonna go back to the kind of the parent directory here, which is, I believe, something July. There we go, June, whatever date, whatever month we're in. And then remember that I've got several different containers. I downloaded this python.sif container, and I downloaded that specifically to show that you can use something like Python as your preferred shell. So one thing that the Apptainer developers did as a convenience to users is they changed all the Singularity environment variables to Apptainer. So you can, instead of passing Singularity _ shell, you can use Apptainer _ shell. That will work as well. In fact, that's preferred. And let's see. I think it's user bin Python. I might be wrong about that. But let's go ahead and say Apptainer shell python.sif. Yeah, I was wrong about that. So now where does Python exist? Here in the container. This is kind of overkill, but I'm going to say find dash name Python to dev null. It's user local bin Python. Okay, let me try this again. Should have saved this. Sorry about that. User local bin Python. Let's try this again. Okay, so now if I shell into this, now that I've got that set as the shell that I want to use, I get a Python prompt. So the same command twice. The first time I just got, a bash prompt because I didn't have what I was asking for wasn't an executable. So it went through that logic in that script and said, "Oh, you asked for something that's not an executable. I'm just going to give you, bash." And the second time I did it, it said, "Oh, no, I found that. And it's an executable. So now you can be in Python instead." So now because it's Python, I have to exit with this funny syntax in order to get out because it's a function. Cool. So let's start looking through some more stuff here. All right. Let's see. I've got like some notes that I wrote down. Yeah. So some other interesting things are if we look at exec. I think this is a really easy one. So all this does is it does that little for loop I told you about before that we're going to talk about in a minute that sources your environment. And then it just executes whatever command you give it with whatever command line you give it. It just execs that.
So it's back to the yeah. Anyway, the colors were weird again when you went out and came back in.
Yeah. Yeah. I'm gonna have to do that every time. What was it? I got it. Oh, set background. I got it saved in my history. There we go. So once again, pretty simple. It's just that little for loop I was talking about.
Yep.
And then it just executes. All right. So let's look at a bit more complicated one. And this will give you some information about like some history too. So if we look at, I think run is one that's a bit more complicated. And let me set that up for everybody. Okay. So once again, the first thing that we do here is we source those scripts that give us the environment variables that we need. But now we've got, this is a pretty complicated script. It's got a lot more to it. It's got a lot of like if kind of test, else if test kind of statements. And the reason for this is because there might be an environment variable called singularity app name. And if that environment variable is set, then we're going to check and see if there's this directory called scif/apps. And then if it's got that app name. And if it does, and underneath of that, if there's another scif/run script. And if it does, we're going to use that as the run script. And so it's kind of rarely used, but there's this whole like architecture in Apptainer that was put in place a while ago, primarily by Vanessa Socket. And what it is it allows you to take multiple different applications and put them all in the same container. And when you do this, it actually exposes the name of the application, which is kind of a groovy trick. It exposes it out to the command line so that you can reference the containerized app at your command line, and then you can get it to run whatever application has been, put in there. And that's kind of cool because the way that all works is just through these bash scripts. It's all just like exposed out to the user through these bash scripts. So one thing that you can do is you can set environment variables, and you can do it, but you can also pass the name of the application itself at the command prompt. And I think that what that does is it actually sets the environment variable through the command prompt, and then these scripts get triggered. So it's kind of cool, and it's an interesting little trick that you can do. And then I believe that in the first incarnation of this, the directory name was a little bit different. The directory naming convention was a bit different. And because this is something that happens at the level of the container, if you start off one way and you decide to make a change, you have to have backwards compatible code in the container itself, as we've seen already. So I think that's why we have the second else if statement that, you know, also says if this is an old container and if this directory structure is like kind of the old way it used to be, then go ahead and use that as well. Okay. All right. I think that's enough of the action commands. I'll let you explore some of the other action commands on your own if you're interested in doing that. I'm going to skip for a moment the bootstrap history. This is an interesting directory. I do want to talk about it a little bit, but instead, right now, I want to skip and start talking about the environment directory. So we saw that pretty much all of our action commands start with a little for loop that says anything in this environment directory, which ends in a .sh, go through and source all those files in alphanumeric order. So that's, the order is important. So we're going to go ahead and source all these files in order. This container was made from a CIF file. It was created by dumping the contents of a CIF file out into a bare directory using the sandbox directive. So because of that, it's not going to have stuff so this file here is for environment variables that were added if the container was originally like a Docker container, and if it was created using a Docker file, it might have environment variables that were added like that. Apptainer will pick those up and it will add them here in this file. The base, I'm pretty sure, is empty, so we'll look at that. So I'm not sure if that's something that's like of historical significance, or if there are still reasons that we might use this base. But right now there's nothing here, so I don't know. That might be something that's changed if you pass certain environment variables at runtime. It might dynamically like rewrite stuff there. I kind of doubt that, actually. So I think this is probably just like for historical purposes. We look at, this should be empty as well. Oh no, okay. No, you know what? I think that it always has this, because this is the place at which this path has to be set. This probably used to be in base, and I'm sure there was some bug or something, and for some reason we had to move it. But this probably ought to be in base, or used to be in base, and we realized there was some reason it can't be anymore. You know what? I'll bet you maybe sometimes within Docker, maybe sometimes they rewrite the entire path. So maybe this fixes a bug there. In any case, if there were more variables here that were added by the Docker file, you would see them listed here down below. Okay. 90 environment.sh. That's the one that gets written whenever you first build the container. So this is it's kind of an important one. Any environment variables that you add in your definition file when you build the container are going to be here. And so you can see that I added originally lc_all equals c. And I added a new path, and that's where these get sourced, and that's where they get added to the container. Okay. There's apps base, and then there's apps, and these both have to do with that same sci_f directory structure that I told you about before. So if you load multiple apps into a single container, these are the .sh files that get sourced, which give them their individual environment variables. So you're different. It's kind of cool because when you, like I showed you before, that there's a mechanism in place to selectively choose a run script based on what application you want to run inside the container. There's also a mechanism in place to give each one of those apps their own environment. So each one of those applications can have their own environment variables, and that's how this works right here.
Within
and then
the
if we
same
look,
container.
kind of an interesting one. Yeah. So depending on how you call the container will have different environment variables set at runtime. Yeah, it's kind of cool.
It is.
And then once again, it's all just bash scripts. So that's kind of like the neat thing about it is that it's all just bash scripts to make that happen. And then I'll show you another cool one. So this 99, excuse me, runtime vars.sh. Once again, let me make that visible. Okay. So this one looks weird, right?
It's different.
Yeah. So there is this, there's a mechanism in Apptainer. There are environment variables that you can set, and I would direct you towards the appendix in the user guide. There's environment variables that you can set, which will allow you to prepend to the path or append to the path, depending on how you set these environment variables. And that becomes kind of important sometimes for various reasons. There are certain bugs that it can fix and so on and so forth. But this is how this works. So basically, we check when the container first runs, if there are environment variables set that will indicate that there are user-defined prepends or appends that should happen to the path, or if we should just overwrite the path altogether. And if these environment variables are set, we're going to go ahead and change the path depending on what new directory structure, what new directory path has been asked for. And then at the end, we'll go ahead and throw those variables away so they don't mess up the environment, because it's not the variables themselves that we want. We want those variables to change the path. So once again, kind of complicated behavior, which is determined by pretty straightforward, scripts. Cool. Any questions before I jump on?
Yeah, I mean, who has the power to change these scripts?
Developers. So,
okay, so this is like Singularity, how it's running, not like I'm taking a container and I'm changing it. This is like behind the scenes. You want to be a part of it, go into the community and hang out with Dave.
Yeah, and Dr. Dave and everybody else. Yeah, it's kind of funny, right? Because this is like the run. This is like the platform, right? This is how Apptainer runs, but it's in the container. And so it's kind of funny because it's like some of the Apptainer runtime actually lives in the container itself. There's like some blurring of the lines there. But yeah, the way that this works is that your installation of Apptainer has these files saved inside of it in Go, actually. And when you create a container, one of the steps that Apptainer does for you is it takes and it builds this directory structure inside your new container, and it plops all these files in here for you. You can go in and edit these if you want to. You're discouraged from doing so, obviously, because you'll probably just break your container. There have been situations in the past where I have edited specifically the environment scripts. But yeah, I mean, that's, if you're doing that, then there's either you're probably doing something the wrong way, which is making things too hard on yourself, or you might be like correcting some bug which exists in Apptainer, which really needs to be fixed at the level of Apptainer, and not just like by hacking your containers individually. All right, so labels.json. So when you build your container, there's a way to add like metadata to your container. Some metadata just already exists. So if we look at this, this is what this ends up looking like. You've got these, you've got these keys, and then you've got these values, and they tell you things like when the container was built, what version of Apptainer was used. Oh, sorry. I think you're telling me this probably.
Yeah. Yes, thank you.
Yeah, you're welcome. Yeah, the bootstrap, the def file that was used and stuff, the way it was bootstrapped basically, and so on and so forth. There's a libs directory which is currently empty, and it's empty because that's where if you run your container with the --nv or the --rockum flags to tell Apptainer that you've got a graphics card that needs specific libraries, that's where Apptainer binds all those libraries for you. It dumps them all into that directory, and then it sets your LD library path so that it'll go and look in that directory for the libraries that it needs. We've got a run script here. That should be pretty clear what that is. Let's have a look at that. So that just, in this particular case, does fortune cal say LOL cat because this is the LOL cal. So let me just show you.
Wait, did that just say LOL cow or LOL cat?
It said LOL cat. And the reason for that, let me show you real quick. So this container does three things. It generates for you a fortune using the program fortune, and it pipes that into a program called cowsay, which makes the fortune appear in this bubble as being spoken by a cow. And then it creates kind of a rainbow gradient color. And it does that by piping the result of the first two operations into a program called LOL cat. So LOL cat is the thing that makes these colors. And so that's why that's the run script. So the start script is pretty similar to the run script. The start script runs by default if you use instances. And if you do something like instance start, and then the name of the container, instead of just like running the container, it'll run the start script instead. This one's empty because I don't use this with an instance. And then finally, there's this Singularity file. Once again, everything's called Singularity within the Apptainer ecosystem. And if we look at that, that's going to be the definition file. Now, here's where things get kind of funny. This definition file, this is not the definition file that I originally used to create this container, right? This is the definition file that was used when I executed that Apptainer build -- sandbox lolcal.sif command. And so what it did is it created a definition file for me based on that. And it said, oh, well, you're trying to build a container from a local image, and the actual image that you're trying to build from is lolcal.sif. And then that was the entire definition file. Now, that's not particularly helpful if you actually want to see how this container was built. That's where this bootstrap history comes in. So what I can do, I've got this Apptainer 0 file within bootstrap history. So if I look at bootstrap history, Apptainer 0, this is the original definition file, which was originally used to create this lolcal.sif container. So the way that this works is if you stay within the Apptainer ecosystem and you continue to build containers from one another that are just CIF files, it will layer on top of it all of your definition files in that directory so that you can go back and kind of go back through the history and see how the container was created. So this is kind of cool. And so I created another couple of definition files to kind of like show this. So I've been using the tree command a lot throughout this, to show this hierarchy. The lolcal.sif container does not have tree installed in it. So I decided to use it as a base and install tree. And so I said, okay, I'm going to grab that container again from Docker Hub. I'm going to use it as a base. And then I'm going to install this command tree. And then I said, oh, okay, well, it also doesn't have them installed in it. So let me make another definition file. And in that one, I'll install them. In this case, I'm going to use, instead of starting from the Docker Hub one, I'm going to start from that tree file that I just built. So now I've got like 3 containers that I built in succession. And if I go into this vim sif file, and I go to .singularity.d, and I look at everything that's there, I can use tree because that was one of the things that I installed. Now this bootstrap history has 2 files in it, and I've also still got, let's see, my Singularity file here. It's in a different place now. So if I said like vim Apptainer, I gotta say bootstrap history, Apptainer 0, this is where everything started. This was the origin of everything, right? So I started by building this lolcow file using this definition file. And then if I look at the second one, this is the one I just showed you, where I went through and I started from the file that I had built, and I installed tree. And then if I want to look at the latest one, that's that Singularity file, which is at the top. There we go. And so we've got the entire history saved of all the different definition files that we used to create this container. Okay, so I think that that's pretty much really quick and dirty tour through all the different, through all the different aspects of the /.singularity.d directory. I'm gonna stop sharing now.
The hidden files. I feel like, you ever go into someone's house and you open up their cupboard, like just like to see like how they organize things? Yeah. I feel like we just like went inside and we saw how things are organized. That's awesome. So we actually do have a question coming in from LinkedIn. So thank you very much. And the question is, do you know a use case to get this deep into Apptainer or to be able to change the Apptainer setup scripts itself? Thank you, Christian.
Yeah. So once again, I have had to change the Apptainer scripts sometimes, actually to account for bugs in Apptainer. So, and sometimes it's not bugs. Sometimes it's like corner cases as well. So, for instance, there have been times where maybe your container needs to run with --nv, and maybe for some reason you already got your own LD library path. And so, but maybe when you run with --nv, it prepends that libs directory to your LD library path, for instance. And so, and what it does is it overwrites some library that you want to use, which is already inside your container. This is like a weird corner case that I've run into before. So maybe what you need to do then is you need to get into those guts and you need to, maybe dump some libraries, make some symlinks to some libraries in the /libs directory. That might work. Or maybe you might need to change the order with which, maybe you need to set one of those scripts, and maybe it's got to be one of the environment scripts, and maybe it's got to be really late. Maybe it's not the 90-environment script, but maybe it's got to be like the last environment script where you prepend instead of appending the libraries that you need onto your LD library path. There can be different things like that you might sometimes have to get into and work with. Or, of course, another one of the use cases is if you find a bug or a potential for enhancement. Like, once again, I showed you how more than one app can be installed in the same container and can be referenced. And all that is just magic that's done with relatively simple bash scripts. So if you find something like that, then you could, not just change it, but actually change it in the source code and go to the developers and create a PR and say, hey, we could make a relatively simple change to these bash scripts in this directory, and it would enable all this new functionality. So why don't we consider that? Now, I will say, these are kind of like the heart of the container. So if you have a suggestion for an improvement, it's going to require a lot of scrutiny, probably from a lot of developers, and there's probably going to have to be like discussions in the community meetings and stuff like that, because this is stuff that is working, and we don't want to make changes to it lightly, right? You could have unintended consequences and side effects.
That's a great little segue into, say, somebody does want to get involved. How do they kind of jump into what it is that you're doing? Because you're talking about bash scripts, but it's also written in Go, right?
Yeah,
So that's probably important to understand.
Yeah. So the way that this works is that I think the last I checked, I think that these scripts just end up being great big long strings that appear directly in the Go code, and then these strings are just basically written out to files by Go when the container is created. So yeah, I mean, it wouldn't be hard to find. You could grep through the code for phrases that are in these scripts, and then you could figure out pretty quickly, based on that, where they exist in the Go code. And then you could do little tests where you like add stuff and then build containers and see if it ends up in the, this would be a relatively easy place to get started. If you're more familiar with bash scripting than you are with Go, for instance, this would be a relatively easy place if you wanted to get started and start messing around with Apptainer and kind of playing with it and seeing how to change things with it. I will say too that there's room for improvement. So we have talked for a long time, for many years. I remember having a face-to-face with Ian Kaneshiro probably 4 years ago, in which we discussed, and this was like shortly after we had created the CIF file. So the CIF file is a new thing, and we're thinking about what to do with it. And we're like, well, maybe we could get rid of all that stuff that's in what it should rightfully be the file system, and we can get it out of /.singularity.d, and we can put it in its own partition in the CIF file. And then at runtime, that stuff can get copied into the container, or by mounted on top of it, or what have you. And it can act like it's part of the file system, even though it's really not. It's outside. It's in the it's in the CIF file itself. So, we never did that, as far as I know. So and that's still like something that could be done, which would arguably be an improvement. So I'm old enough too that I can remember before this was even a thing. It used to be there was no /.singularity.d directory, and Greg rightfully said, hey, we've got to have this directory where we put this metadata and these drivers, and we have to have a place for all this stuff to work. And I was kind of against it, because I was like, what happens? And this is like a stupid corner case, which will never ever happen. But it was like, what happens if I create a container and I create the directory /.singularity.d when I create the container, and I install a bunch of stuff in it, and then Apptainer comes along during the build process and obliterates all that and puts all this other cruft in it. That's a weird corner case that could really mess me up. And, it could happen, fine. But I think everybody was like, yeah, but I mean, we need a way to do this. And I mean, that's like a 1 in a million corner case. So let's not worry about that.
I mean, that could probably happen anywhere, anytime, not just with Apptainer though, right?
Yeah, I mean, there's lots of stuff like this in computer science. I feel like, just generally, like I kind of feel like this is the way Bash got to be what it is, because somebody was like, okay, well, David Bourne or whoever it was, somebody who created this stuff way back in the day. I don't know. Don't yell at me if you're still alive and you created it and this is not what happened. But so I think somebody was like, all right, look, we have all these commands, but sometimes we need to pass strings. And sometimes it's like the shell, just based on the placement, the shell understands that they're strings, but sometimes it doesn't. So how are we gonna fix that? Somebody's like, just put quotes. We'll just quote it when it's a string. And they're like, okay, put it in. And they did it. And then somebody was like, hey, I got a problem. I need my string to have quotes in it. And they're like, oh, well, we'll make single quotes, like the magic quotes that allow you to have double quotes in your string. I'm like, cool, all right. And then but it just keeps snowballing, right? Because it's like somebody's, but I need single quotes in my string. Oh, well, we'll put a backslash in front of the single quote, and that's an escape character, and that means that, this is a literal string, Well, what if I need a backslash in a single quote, And it just keeps going and going, and so you've got like all this. And I swear, I think that's how bash strings developed.
Right. And one of the challenges of trying to understand and learn, like how the heck you got where you're at. Oh, that's awesome.
Well, and you see a lot of the history in this stuff too, because it's like on the code side, you can always just rewrite and you can always just get rid of stuff, and it's hidden from the user and it's hidden from everything. So you can always, as long as it operates in the same way, you can refactor. But this is in the image, right? This is in the container. And on the container side, there are containers sitting on Docker Hub that have been built 5 or 6 years ago that still need to run. And so because of that, you can't just say, oh, we're going to make all these changes and it's going to operate the same way. Your code still has to be able to look at those old containers and be like, oh, I remember when we did things this way. When we did things this way, I had to, operate and, X, Y, and Z. And so that's why you end up seeing like this legacy stuff in this directory.
That's wild. Thank you, Dave Godlove. That was fun. All right. So tell us how we can get involved in the Apptainer community. Where is it that you hang out and do this kind of behind the scenes magic?
Yeah. So most of where I hang out is just on GitHub. And so like a great way to get started with the Apptainer community is to just go to GitHub and start looking at the issues that we're having. There's a whole slew of issues. Or, if you have a bug or a suggestion for an improvement, go there and raise an issue. And if you really want to get interested, and that's enough. I mean, you're a member of the community right there. If you want to go a little bit further, don't just raise an issue. Take a crack at making a PR. Take a crack at making a pull request. And another thing that you can do is attend. There are twice monthly community meetings. I think it's like the first and third Tuesday of every month. And we have a Slack channel. And if you're in the Slack workspace, it's referenced at various places and different websites and stuff like that. So if you're a member of the Slack workspace, then Dr. Dave will send out automated reminders about these community meetings. And so, you can like raise an issue and then you can come to the community meeting and there's a time to talk about stuff. And you can say, hey, I want to talk about, this issue I raised and see what the community thinks about this, if this would be a decent enhancement or if other people are experiencing this bug, stuff like that.
Awesome. All right. So our behind the scenes little magic people, we'll make sure that you guys get those links to the GitHub repository and then also the Slack workspace. Dave, is there any kind of like final thoughts you want to leave people with about the Singularity? What is it? /singularity.d.
Yeah. No, it's just cool, I think, to be able to look at some of the, like, because once again, this shows you some of the history of Apptainer and shows you some of the internals. And I think, sometimes it's good to kind of peek under the covers and look at some of the stuff a little bit. One thing, it's kind of unrelated, but as we close out here, if you have any, like, requests, so we've been doing this ongoing container education series for a while. And I'm like kind of trying to think about what topics would be interesting and, what to talk about. And we've been doing it for long enough that I'm kind of starting to forget things that we've already talked about and things that we haven't. So like, I'm going to ask any of our viewers, if anybody is interested in like any, topic for a future webinar, please let us know. I guess at like ciq.com, there's a contact us page. You can reach out and send us an email there. Or if you want to make a comment on, one of the videos or something like that, just let us know, because I'd be happy to go through something totally different or something I haven't thought of with containers, and not just containers, but with our other stuff, Werewolf, fuzzball demos, just anything you can think of. If there's anything that you want to see us do in a webinar, just let us know.
Yes, absolutely. 100%. Thanks, Dave. And I mean, you kind of did like a really beautiful wrap up there. So just make sure that you guys like and subscribe and share this. Put the little tick on the notifications. We are live pretty much every week, give or take. I think we might do a recorded one on 4th of July, just kind of, I think we might take that day off. But we are definitely here for you. So check out CIQ.com. We're doing a lot of really cool stuff. Just as a little reminder, if you guys are still in CentOS 7, happy to talk about CIQ Bridge, where we're, providing companies those backported security updates that they need so that they can stay stable and secure while they are migrating. So we are going to just publicly, encourage the migration off of CentOS. We're happy to help you with that. And of course, we got Rocky and Werewolf and Apptainer and Ascender and, Fuzzball on the horizon. So lots of really fun stuff. And we'd love to chat with you. All right, you guys. Well, hope you have a really wonderful day. Again, happy birthday, Zane Hamilton. Thank you, Dave Godlove, for being here. Yeah. All right. See you next week. Bye-bye.